formula, which you may hear called compound angle formulae. So what do we mean by addition formula or compound angle formulas? We mean formulas where we have sine of A plus B, or cos of A plus B, or tan of A plus B. So what I'm going to do is go through and show you some basics and just do a couple of examples of the formulas and how we get the formula here. So first question to ask here is, does sine of 30 plus 60 equals sine of 30 and sine of 60? So can we just kind of, put the sine through the brackets like that? So let's check this out. We know the exact values. So we know the left-hand side there is just sine of 90, which is exactly 1. We know sine of 30 is a half, sine of 60 is root 3 over 2, which is about 1.37 when you do that on your calculator. So clearly that's not the case. We can't do that, right? So big cross through doing that. What we need to do is develop a formula so that we can do that. Okay, those brackets don't mean multiply. So what we're going to do is come up with the formula. This formula works for angles that are less than 90 degrees, acute angles, but it's true for any size angles. Okay, you don't have to know this proof. There's another proof on the handout, but I'm going to go through it really quickly. You can fast forward to past this if you want to. Let's start with this rectangle, and let's say the length of the diagonal is 1. What we do is rotate the rectangle through an angle A. So now we're looking at this angle here, which is A plus B, and I want to know, we'll get a formula for sine of A plus B. So knowing our right angle trigonometry, we know sine of A plus B, or sine of any angle, is opposite over hypotenuse. So in this case, the opposite is length H here. So what I'm going to do is split length H into two different bits. Okay. Now that angle there is 90 minus A, so vertically opposite angles, that's 90 minus A. So that angle up there in the corner is A. So now let's look at these two right angle triangles we're going to consider. We're going to consider those two lengths there. So we've got this triangle, RMQ, and then we're going to add on that red line there, which is triangle QPT. So we're going to add those two together, and that gives us the total length of H, which is going to be sine of A plus B. So let's consider those two triangles and see what we get. For this red triangle here, sine of A is QT over A. So QT is A sine big A. In this little triangle up the top here, we've got, and we're trying to find the length of MR, this length here. So cos of A is MR over B. So rearranging that, we get MR as B cos A. Cool. So the height there is just A sine A plus B cos A. That's the height that we need. And now that we've got that as one, we can also say that cos of B, adjacent over hypotenuse, is A. And we can say sine of B is, that's in this triangle here, B over 1. So sine of B is B over 1, which is just B. Now, if I put that back into this formula here, remember H was A sine A plus B cos A. So we can put that in and we get this formula here. So that's the height, sine A cos B plus cos A sine B. There's the formula that we need for sine of A plus B. So when I get sine of 30 plus 90, or sine of 30 plus 60, the one that was the one we did, it's actually sine 30 cos 60 plus cos 60 sine 30. That's the formula that we need. We can get all the other addition formula by using the unit circle or considering the graph and looking at the symmetry. So for example, cos of minus B is the exact same as cos of B, and you'll see that on the unit circle. You can say sine of negative B is just negative of sine of B. Again, you can get that from the unit circle. So if we use those two facts, we can work out the other angle identities. Also this one here, cos A and sine of 90 minus A are the same thing. Right, and so that's another important one. Cos of A and sine of 90 minus A, same angles. Okay, so also we'd have sine of A is cos of 90 minus A as well. Looking at the unit circle or right angle triangle or the graphs as we've done here. So if we use all that now, we can replace, in that first formula that we found, replace A with B with negative B. And we get this, cos of negative B is the same as cos of B, sine of negative B is the same as negative sine B. So now we get this identity, which is the identity for sine A minus B. In this formula here, we replace the A with 90 minus A, and we end up with getting, on the left-hand side, cos of A plus B. Okay, and so that's cos A cos B minus sine A sine B. Notice when it's cos A plus B, you put a minus there. And same thing, we're going to replace B with minus B. And in that formula there, we get this. Cos of minus B is just cos B. Sine of minus B is minus sine B, so this is going to end up being a plus. And there's the formula for cos of A minus B, with a plus in between them. These formulas are always given to you, but I'm just going through how it is that we get them. So the same formula for tan A plus B, really confusing. Tan is sine over cos, so we put in the formulas for those two. Divide everything by cos A cos B. And the reason we're doing that, because we get all this cool cancelling going on, and we end up with that, tan A plus tan B over 1 minus tan A tan B. Again, you're given all these formulas, I'm just showing you how it is that we magically get them. Okay, so how can we now use those formulas, and how do you see them in questions? First way you'll see it is asking for the exact value of angles that aren't nice, like 30 and 60 and 90, and even multiples of 30, 60 and 45. So sine of 135 is just sine of 90 plus 45. So we could use the formula for sine of A plus B, sine A cos B plus cos A sine B. And now we know all these exact values. We know that sine of 90 is 1. We know that this is the square root of 2 over 2. We know that this is 0. We know this is square root of 2 over 2. So we put all that in. We get square root of 2 over 2 or 1 over root 2, same thing. Okay, so that is sine of 135. That's how we do that using the addition identities. If you have a look at this problem here, sine of 15, very similar. Sine of 15 is sine of 45 minus 30. So if you're ever given one of these, you just have to think of what angles that are multiples of 30, 60 and 45 can I use to get that angle. So sine of 15 is sine of 45 minus 30. So using the formula for sine A minus B, that's sine A cos B minus cos A sine B. And then we just put in the exact values that we know for each one of these and simplify. So root 3 over 2 root 2 minus 1 over 2 root 2. Okay, and that gives us the exact value that we're looking for. Root 3 minus 1 over 2 root 2. Now notice if you just put sine 15 on your calculator, pressed equals, it would give you a decimal, but it perhaps wouldn't give you this exact value. So here we're looking for finding the exact values. Here's one more, cos of 75. So 75 we could write as 45 plus 30. The angle identity for cos of A plus B is cos A cos B minus sine A sine B. So then we just write in all of the exact values for those 4 different things right here, and then we simplify. So root 3 over 2 root 2 minus 1 over 2 root 2. So it's very similar to the other one there. And we can multiply the bottom line by root 2 to get that. Here's another common question that you'll get in the exam using these addition formula or compound angle formulas. If you're given 2 angles and their exact values of cos or sine, you're able to work out sine of A plus B or cos of A plus B or tan of A plus B for these angles. So for this one here, we're given cos A and sine B. Here's how you do this problem. If cos of A is 5 over 13, if we just look at this triangle, we've got cos of A adjacent over hypotenuse, 5 over 13, and then we just need to fill in this other side here using Pythagoras. So in this case here, it's a nice easy one because we know a 5, 12, 13 triangle. So it's easy to get what those ones are, to get the other side is. For the other one, we're told that sine of B was 24 over 25. So again, in this other triangle, opposite over hypotenuse is 24 over 25. Use Pythagoras to find the other side length, which is 7. Now, once we've got these 2 triangles, we can know sine, cos and tan of A and B and put them into any formula. So this one here is asking for sine of A plus B. So the identity is sine A cos B plus cos A sine B. So sine of A, we're given 12 over 13. Cos of What else are we given? Sorry, we're given cos of A, right? So we want sine of A. So we go across here, sine of A, opposite over hypotenuse 12 over 13. So that's where we put 12 over 13 there. Cos of B, go over to our triangle. Cos of B is 7 over 25. Cos of A, this one here, cos of A is 5 over 13. And then sine of B is 24 over 25. So we put all that in, get our calculators out, making sure that we're working just with the fractions, and that gives us 204 over 325. So that's the exact value of sine of A plus B. I could have done that also for cos of A minus B, cos of A plus B, sine of A minus B. I could have done it for any of the compound angle formulas for this problem. The last kind of way you're going to see these used are in solving equations, solving trig equations. So in this one here, we want to solve cos of x plus pi over 4 equals root 2 cos x for all angles x between negative 2 pi and 2 pi. So this is telling me that I want the answers definitely in radians. Whenever you see one of these, you want to expand out using that formula. The left-hand side, if you've got sine of x minus pi over 3, you want to expand out using the formula. So that's the first step that we've done right here. Cos of A plus B is cos A cos B minus sine A sine B. So I've just replaced the A with x and the B with pi over 4. We know the exact values of cos pi over 4 and sine pi over 4. 1 over root 2. Now 1 over root 2, yes, we can write that as root 2 over 2 also. Okay, so either one of those would be fine. Now the next step is to multiply both sides, multiply everything by root 2 to get rid of those fractions. So that makes things a lot nicer. We then subtract cos x from both sides, and we now got an equation with minus sine x equals cos x. The trick for if you've just got sine and cos is to divide both sides by cos, and that gives you sine over cos, which is tan. So we're looking for tan of x equals minus 1. That's a nice easy one. Your calculator will give you one answer, but there's the 2 there. Minus pi over 4 is one answer. Positive 3 pi over 4 is one answer. That's this angle here. Negative 5 pi over 4 will be another answer. That's this one here. And also, if we go 7 pi over 4, so that's this angle here. So between negative 2 pi and 2 pi, there's actually 4 solutions there for that final equation. So in general, solving these equations, you just want to expand out and then use your basic equation solving skills to get the answers.